case, we have a data that was necessarily restricted because of computational reasons only to the state of New York. In reality, we had data for the entire East Coast. And we have predictions, though, that happen in continuous space and in continuous time, while actually here we have it only at the monthly level. These are 3 different months. And we have the probability of occurrence of observing this phenomenon. And this provides a lot of helpful recommendations for people that are in charge for surveillance and to control this type of diseases. That, let's not forget it, they are lethal. And another area of application of the method that I described is the study of sea turtles' nesting site patterns. Here you have the easting of the beach, and here you have the density, the probability of observing nesting sites. So here if you look at the data, this is actually the estimation result. We were able to find several patterns that go in the spatial dimension and in the temporal dimensions. And we were able to actually observe a migratory phenomenon of this species of turtles that, let's not forget it, is endangered as a consequence of the building of a pier in the beach where the measurements were conducted. Other areas of research that I am involved in, and I want to give you some examples, are, for instance, this is more related to the big data side. And this is a data set that was previously discussed by Professor Cornelion and the Oceanography department. We have sea surface temperature data that are observed on the satellite. Here, this is a typical case of big data. Large amount of information, very high resolution. However, it's a very complex data set that calls for advanced modeling. So when you have the clashing of advanced modeling and big data, you have really the explanation for high performance computing. Here I have also another example. Also, this is an example of collaborative research with Professor Jenkins here and postdoc Dr. Spinett. And we are trying to understand what are the drivers of nitrogenic activity in the Narragansett Bay. And we know that there are several factors that are driving this. The dissolved oxygen, environmental variables, organic matter, and we have several different variables. We have a very complex process that we are trying to make sense of. And here we have an example of different sources of data that are not necessarily at the same resolution. Here we have some buoy data that are collected in the bay, and we have chlorophyll, we have temperature, we have dissolved oxygen. This is high resolution data. We have observations every 15 minutes collected by the buoy data. However, we have only nitrogenic activity only collected at a specific point in time during the cruise when the data were collected with the boat. So this type of data analysis requires sophisticated type of modeling because you have different sources of data that are not observed at the same sequence or at the same resolution. So again, high performance computing can be very effective in providing a supporting tool for our research in order to try to help us to make sense of the complexity of reality. That sometimes we can try to investigate it using brute force and large amount of data, trying to find patterns in this data using data mining. Sometimes we have to, on the other hand, trying to combine different sources of knowledge, and then the effort is more in developing sophisticated models. So I hope I give you a little bit some hints of what I'm doing. Thank you.
We have time just for a couple of questions. If anyone has a burning question, or you can wait until we meet it at the round tables. We have an overarching question that we'd like you to answer for us, but does someone want to go Okay, one at each table, but maybe they want to consolidate at the tables. But I need a copy so I can read the question. Does anyone have a question of any of the speakers at this point in time? Lisa?
No, I'm sorry. I just think the speakers are incredible. I love the list of who the speakers were later, but I also was just wondering, is there any way we can maybe even do one roundtable or
One or two, yeah, that's what I'm thinking, yeah.
consolidate?
Yeah.
The same set of questions.
Okay. So where does the University of Rhode Island want to be in the era of big data? And there's sub-questions and bullets and an opportunity for you to go in a completely different direction. We just want to